All right, so today we're going to dive into a really fascinating piece of engineering software called the PAT Converter. We're going to peel back the layers on what looks like some pretty complex Python code and show you the story behind it. A story all about solving a real and, frankly, a really frustrating problem for antenna engineers.
So here's the game plan. We'll kick things off by looking at the data mess that made this tool necessary in the first place. Then we'll explore its coolest features. And finally, we'll see the massive impact it has on the day-to-day work of an engineer.
Okay, so to really get this, you have to understand a problem that every single antenna engineer deals with: radiation pattern data. This stuff is absolutely critical, but man, it shows up as this total chaotic mess of different, completely incompatible file formats.
For instance, you might get something like this, a standard CSV file from a simulator like HFSS. It's all neat and structured with columns for angles and values, but here's the thing. It's just one dialect in a whole sea of different data languages.
And then you'll get something completely different. A piece of test equipment might spit out a PRN file. And just look at it. It's a whole different beast. You've got metadata, things like name and frequency, mixed right in with the numbers. The whole layout is unique.
And hey, why not add one more to the mix, right? You might also have to wrestle with a PAT file. And again, totally different rules. It's got its own specific 5-line header before you even get to the data. You can just imagine trying to make these three talk to each other. It's a total nightmare.
Look, this chaos isn't just an annoyance. It is a massive bottleneck that slows everything down and just begs for errors to happen. So you have to ask, right? How on earth do you build one single tool that can actually understand all of this?
And that, my friends, is exactly where the PAT converter comes into play. It was built from the ground up to be the elegant solution to this exact mess.
Probably the best way to wrap your head around it is to think of it as a universal translator. It takes all those messy, different data languages we just looked at and smoothly translates them into one single, consistent format that an engineer can finally work with.
So how does it pull this off? Well, this is the secret sauce right here. Instead of some huge clunky function trying to do everything, the code is smart. It has these dedicated little parsers. Each one is basically a specialist, fluent in the language of one specific file type, whether it's an HFSS CSV or one of those tricky PRN files. Okay, so that's the how. But what does this actually look like for the engineer who's using it? Let's walk through that because it's surprisingly simple. It really couldn't be easier. It's basically a 3-step process. First, you just load any file, and the software is smart enough to figure out what it is on its own. Second, the app instantly crunches the numbers for you, calculating key things like beam width, and boom, step 3, it turns all that raw data into a really clear, useful graph. And check this out. With just one click, you can flip between two super important views. The polar plot gives you that big picture, 360-degree view of the antenna's shape. It's really intuitive. But then you can switch to the planar plot, which kind of unrolls it so you can really dig into the nitty-gritty details, looking at specific angles and amplitudes with total precision. But wait, there's more. This tool isn't just a fancy file viewer. This is where it gets really cool. It lets engineers build and test entire virtual systems, complex antenna arrays, without ever having to touch a single piece of hardware. So first, let's do a super quick refresh on what an antenna array even is. It's not just one antenna, it's a whole group of them working together as a team. By controlling the spacing and timing just right, engineers can shape the signal into this really focused beam, which is, absolutely critical for pretty much all modern wireless tech.
So how does the app actually build one of these virtual arrays? Well, the engineer just has to plug in a few simple numbers. How many antennas are in the array, what frequency they're operating at, and how far apart they are. That's it. The software takes it from there.
And this is the really magical part. The software takes the data from just one of those antennas, and based on those few numbers you entered, it does all the heavy lifting. It runs all the complex math to show you exactly what the final combined beam is going to look like. It completely takes the guesswork out of the equation.
Okay, so we've talked about data and calculations, but honestly, one of the most powerful features is all about something simpler: organization. It's about giving you a permanent personal library for all of your work.
And this is a perfect example of how some abstract bit of code becomes a massive real-world win for the user. In the code, there's this thing called a database manager. But for the person using the app, that's not just code, it's the engine that creates and manages their own personal searchable library of every single pattern they've ever worked on.
And you know what? Under the hood, it's actually pretty straightforward. Every time you import a diagram, it gets saved to this simple little database. It stores a name you give it, what type of pattern it is, and all the raw data for the angles and values ready to be pulled up whenever you need it.
So what does that mean for the user? Well, it's a huge productivity boost. You can import hundreds of files at once, everything is saved automatically, even when you close the app, and you get this awesome visual library where you can just browse through thumbnails, click on one, and bam, you're right back in your project. All right, let's put it all together. What's the real-world impact of all this? When you combine that smart data parsing, the powerful visualization tools, and this amazing library system, you literally change the way engineering gets done.
I mean, just look at this. The difference is night and day. The entire workflow gets a complete makeover. You go from this painful manual process of cleaning data, copying and pasting, and hunting for files, to this slick, automated, centralized system where everything just works. The risk of making a mistake plummets, and the speed you can design at just skyrockets.
And really, that's the whole point, isn't it? This tool's true value isn't just that it can convert a PAT file. It's that it saves an engineer's most precious resource, their time. It cuts down on errors and empowers them to design better systems, way faster than before.
And that kind of leaves us with one last big question to chew on. Sure, this story is about antenna engineering, but the principle behind it is universal. It makes you wonder, right? What other complex, data-heavy fields are out there just drowning in information, waiting for their own version of the PAT converter to come along and finally bring some order to all that chaos?